Alright, so let's take a look at this example here. So our first step is to simplify if you can. So we have parentheses, so we're going to take the number in front, and remember you have to look in front of a number to tell if it's negative or positive. So that 3 minus 5, you're going to look at it as a negative 5. So we're going to do negative 5 times 2x. So negative 5 times 2 is negative 10x, and then here we're going to have a negative 5 times a negative 3, and that is a positive 15. And then I'm going to bring down the 3, and now we have like terms, so we can combine the 15 and the 3 together. So that's 3 plus 15, and that's 18. So I like to put my x, so I'm going to bring this down first, and then the 18. It doesn't matter, you could do 18 minus 10x, up to you. Okay, now we look on the right side, and these two cannot be combined, so I'm just going to bring them down, because one has an x and one doesn't. Okay, so that was step 1, we simplified. The next step is we can only have one variable term, and it has to be on one side. So in this problem here, we have variables on the left and the right, so you're going to pick one. So I'm going to pick this one, and I'm going to add 10x here. Now when I do that, both the variables zero out. When that happens, you're going to bring down what's remaining in the problem. So I have an 18 here and an 18 here. So when the variable term cancels out, so it makes 0, you bring down what's left and you read it. If it makes a true statement, another word for that is it's an identity. So like think about your identity, right? You can cut your hair, you're still the same. So that's how I remember it, identity. They're the same here. So this means the variable can be replaced with any number at all. So there isn't just one answer. Like this problem up here that we did, the answer was negative 100. That was the only number that if you replace it for the variable would make both sides equal. So when this happens and the variable cancels out and what's left is true, that means any number you want. So pick whatever number you want, and if you put it in here for the x's, it makes both sides work. So all real numbers are going to work. So if you're asked to write your answer in set builder notation, remember the word set means these, you're going to have these curly brackets. And the set builder notation, whatever variables in the problem would go first, so since it's x, and then there's this vertical line. That vertical line right there means such that. Okay, so it says x such that x is all real numbers, so it could be any. So x is all real numbers. Be any number. So that's like the proper way of saying all numbers work. Now there's a symbol for it if you're allowed to use it, if the directions allow it. You put two vertical lines and then wrap it around. It looks like an R like that. That's the symbol for all real numbers. Okay. So what is the answer to this problem? What would you need to write on a test or when you're answering this? You would write all real numbers. If it asks you to write it in set builder notation, then you would write it like this. Okay, so again, you would either write it like this or you would write it like this depending on what the directions ask for, if it asks for in set notation. Okay, so let's go ahead and try another one here. So the very first step is you want to simplify. So we can put together the 2 and the negative 3 because they both are like terms. They don't have variables. So 2 minus 3 is negative 1. And then I'm going to bring down this 5x. So I could also write this as 5x minus 1. Doesn't matter which one goes first. And then on the right side, we're going to distribute. So we're simplifying here. So we're doing 5 times 1 is 5x. And then 5 times 4 is 20. Okay, then the next step is we can't have variables on both sides. So we need to pick one of them to remove. So I'm going to do minus 5x to make this 0. And then I'm going to bring down what's left. So the variable cancels out again in both of these problems. What's different here is when you bring down what's left here, this is not true. -1 does not equal 20. So this is a false statement. So another word for that is it's a contradiction. So it's not true. So when you get a false statement, it means that there is no number at all. So again, this problem up here had one answer. This problem here, any number can go in for the variable. Whereas this problem, when you get a false, means there is no answer, no solution. So if you're asked to write your answer as a set in Set Builder, it's going to be empty. You're not going to put anything inside there, nothing, just leave it blank. And the symbol for no solution is going to be a 0 with a slash through it. So what would I want on a test? How would you write your answer? You can write no solution. So I would accept if you wrote that. I would accept if you put the empty set like that, or if you wrote empty set, I would take that as well, or if you put the symbol. So those are all 4 good ways on a test to show me you know that it means no number would work. Okay, so let's demonstrate this. So again, I want you to see the difference between these two problems. So if I go back to the original problem and I plug in any number I want. So if I go back to this problem here, 3 minus 5 parentheses, and then for the x, I could pick any number. So you guys pick your own number. I'm going to pick 5. Just randomly picked 5. I like 5. Now this 2 is next to this x, so I know it needs to be multiplied. So I could put it in parentheses, but since this one's already there, I don't want to get confused, so I put the dot for multiply. Okay, and then on this side, I have -10, and then I have that x, and it's right next to it, so it means times, and I use 5. And this is what this means, any number. So I just randomly picked 5. Now if I type this in my calculator, I would have 3 minus 5 parenthesis 2 times 5 minus 3. So I just type the whole left side in, and I get -32. Now I do the right side here. -10 times the 5 that I randomly picked. Again, you could have picked a different number. Just make sure you put it the same thing in both of them. And we get the same thing. So that's what it means to be all real numbers. Any number you want, you could put here and it will work. Whereas with this problem here, this is a contradiction. I mean, if you think about it, if you have -1 plus 5x, and then over here you have 5x, so you have the same thing here, and you're adding -1, but here you're adding 20, there's no way for them to ever come out to be the same. So I just want to mention something that I've noticed in some of my students' works in the past. So if we take a look at, for example, this last problem we did here, we had -1 equals 20. Sometimes I have students that go a step further and they'll do something like this. They'll go add 1, and then this would make 0 equals 21. So if you add 0 equals 21, that still means no solution. That's not true. 0 doesn't equal 21. So even if you go a step further, you're going to know the right answer. Now up here with the 18 equals 18. So if you didn't stop there and you added an extra step that you didn't need and you did this, you're going to have 0 equals 0. So instead of 18 equals 18, if you did an extra step that you didn't need to, you'd have 0 equals 0, which is fine because that still is telling you it's true. 0 does equal 0, so you would know it's all real numbers, even if you added that extra step in the end.